mandatory to organize our.
I am Dr. Sureshkumar. I am working as Associate Professor in the Department of Computer Science, AJK College of Arts and Science. I am going to take computer graphics. First of all, what is computer graphics? Computer graphics is a field of computer science where creation and manipulation of pictures are carried out with the help of computer. That is called computer graphics. So where we can apply for the computer graphics technique. So it can be used for animation. First of all, we must know idea about it. What is animation? Animation is nothing but moving the picture or object on the screen. That is called animation. So whenever we want to do the animation technique, we are going to perform. There are three kind of operations. So what are the operations we are going to perform for animation? That is, one is translation, the second one scaling and rotation. This we could call as, it is called transformation. So that type of name, it is called basic transformation or 2D transformation or geometric transformation. So there are major three kind of operations. One is translation, scaling and rotation. First one, that is called translation. What is translation? The translation is nothing but the original image, it can be transferred into translated image. That is called translation. For example, we can say the one image, it is in the original position, that we moved some more places on the other on the screen. So that is called translation. That is called, we can simply say about it is a shifting from one place to another. That is called translation. For example, we can find out the formula for translation. How we are going to do the formula for that? So that is whenever we want to get the xy, it is called original. The x dash and y dash, it is called translation. That means after transfer the image. So what is the formula to find for the translation? The x dash is equal to x plus dx and the y dash equal to y plus dy. So what is x dash equal to x plus ds and y dash is equal to y plus dy. That means the x direction, it can be translated from original to other. The simultaneously not only for transfer to x and as well as we are going to transform the y also. So how we are going to define the formula for final formula for translation? Here the x dash equal to x plus dx and y dash equal to y plus dy. So here the t is called as translation parameter. So what is t? So it is nothing but the translation vector or translation parameter. So based on the t value, we are going to translate the image from original to destination. So that means when we are going to give the value, for example 2, if we are giving the t value is equal to 2, so we can, some more distance it has been moved from the original to destination or the object. So and we are giving, for example, t equal to 3. Some little more portions has been extended from the original to the destination. This is what we can difference is finding for the value of the t. The t can perform based on that we are going to translating from original to destination. But here the t is nothing but it is called translation parameter. This was the first operation, and we can have the second one, that is called scaling. So what is scaling? First of all, you must know idea about it. What is scaling? The scaling is nothing but the measuring of the image size. Scaling is nothing but measuring of the image size or object size. So for example, we can say, so the scaling operation can be performed. There are two ways. One is scale up and another one scale down. What is scale up? Scale up is nothing but increasing the image size, and scale down is nothing but decreasing the image size. So whenever you want to take the increase of the image size, you want to get so we can doubling of the image or tripling of the image. For example, we can say it is called as doubling or tripling. That is called increasing of the image. And whenever you want to perform for decreasing of the image, you can decrease the size of the image. That means we can quarter down of the image, like that we can change the inform. That means resize of the object or image. That is called scaling. Now we could find the formula for scaling. So what is the formula to find the scaling? That is x dash equal to x dot sx and y dash equal to y dot sy. Here the product operation is possible to do a scaling operation. That means we can have about, so whenever you want to the multiply, you are going to get if you are giving s value 2, then you can the size has been increased for twice. If you are giving the value, if you are giving 3, the size has been revised for thrice. Like that, you can give the value to find the formula based on the value of the S. Here the S is nothing but scaling parameter or scaling vector. So what is the final formula for scaling? So the scaling, there are 2 ways we are performing. One is scale increasing or scale decreasing. That means increasing something but scale up operation we are doing, and decreasing something but scale down operation. Whenever you want to increasing that, so we can give the value S equal to 2, 3, likewise we can give. Whenever you want to decreasing of the image, you want to give the value S equal to 1 by 2 or 1 by 4, like that you can decreasing of the image. This is the scaling. So scaling is nothing but, it is nothing but simply you can say it is the resize of the object. So the third method, that is the final one for the basic transformation or 2D transformation or geometric transformation, that is called rotation. So what is rotation? The rotation is nothing but, based on the theta value, we are going to rotate the image wherever on the screen. So based on the theta value, we can rotate wherever in the screen. That means, if you are giving the theta value, it is 90 degree, we can rotate some more portions, we are going to rotate it. We can give the 180 degree, you are going to opt down on the portion, we can rotate it. You are going to give the value 270 somewhere. So 360 means again we are going to get the one completed circle we can. So like that, we are going to rotation is nothing but based on the theta value, we can rotate wherever on the screen. That is called rotation. Then what is the formula to find the rotation? We are going to get it here. The rotation is nothing but we can have about the x dash equal to x cos theta minus y sin theta, y dash equal to x sin theta plus y cos theta. This is the final formula for rotation. So based on the theta value, we can rotate wherever in the screen. That is called the rotation. The majorly we can classify by using the basic transformation or 2D transformation. There are 3 operations we are performed in the method. So the next thing is we can have, there are some kind of additional transformation or other transformation. That is called reflection and shearing. What is reflection and what is shearing? We could classify with these 2 methods. One is reflection and shearing. Do you know that the very well about reflection is nothing but just like on, it is a mirror image. So whenever we are going to see our face and all on the mirror, so it will be reflected in the same image. So that is called reflection. And we have the shearing is nothing but the distortion of the object or image. So while we are a distortion between the x-axis and as well as distortion is between the y-axis. These 2 are the kind of additional transformation or other transformation. So whenever we are going to do the matrix operation, how we are using here. So in general, when you want to perform a complex transformation, you usually make it by combining a number of basic transformations. For example, we can say about equation for Q. However, it is to read because scaling is done by matrix multiplication and translation is done by vector addition. In order to represent all transformations in the same form, computer scientists have devised what are called homogeneous coordinates. So that means they are simply a mathematical trick to make the representation be more constant and easier to use. For example, you can say the matrix vector representation. Here, we are getting for the matrix formulation. That's what we are having about it. It is called as matrix vector representation. Here, Q equal to x dash y dash 1 is equal to t star p. That means 1, 0 dx. We are going to get it 0, 1 dx, then 0, 0, 1. And we have a product we are using for star x, y, z. So that we are taking in the x dash and y dash. Finally, we can have the same operation. This is used for matrix vector representation of rotation. Where x dash is and y dash is equal to the cos theta, then minus sin theta, then sin theta and cos theta. This for the matrix representation for the rotation. And we have the composite transformation. Another kind of thing that is called composite transformation. Here composite transformation, it is nothing but, so we can have, there are some kind of thing, the same repeated operation we have done the composite transformation, that is translation, scaling and rotation. If between the translation, we are going to get it here. If 2 successive translation vectors tx and ty and tx1, tx2 are applied to a coordinate position p, the final transformed position p dash is calculated. P dash equal to t, then we can have p equal to t of tx2, ty2 into then T of Tx1 comma Ty1 dot P. And we have that is T of Tx2, then we have T of Y2, then T of X1 comma Ty1 dot P. This for the composite transformation of the translation where P and P dash are represented as homogeneous coordinate column vectors. So what is the homogeneous? Whenever you want to get some kind of the parameters you are using that both are related to, that means the same type of thing. If you are taking for that the image representing for composite transformation, you are going to get the homogeneous referred as, if you are using for 2D, two-dimensional, you can use for the 2D images like. You can use for 3D if you are using for that. You can use 3D. For 2D image you have selected, so for all the vector or the variables, everything it should be the homogeneous coordinate column vector. So then we are getting for the scaling, the second thing of method of the matrix representation for composite, that is called scaling. This concatenation transformation matrices for two successive scaling operations produces the following composite scaling matrix. So like we can have how we are defining the matrix formulation. By using the scaling, so you can have like there are S2, then 0, 0, then 0, S1, 0, then 0, 0, 1. So similarly, we can take it in the product of that, the S1, 0, 0, then 0, S2, 0, then 0, 0, 1. So finally, you are getting for that, we can have the S of S2, comma SY2 dot S of SX1, comma SY1 is equal to S of SX1 into SX2, then same similarly SS1 plus SY2, the rotation. So here we can, using for the composite transformation in the method of rotation, two successive rotations applied to point P produce the transformed position, like P dash is equal to R of theta 2 into R of theta 1 dot P. So here we can R of theta 2 dot R of theta 1 dot P. Here we represent as R, it is called as rotation. The P dash is called as the transformed composite transformation. So here P is called as the original position of the image or object. Here we can, using the by multiplying the two rotation matrices, we can verify that two successive rotations are additive. Like we can have R of theta 2 dot R of theta 1 dot P is equal to R of theta 1 plus R of theta 2. Here we can use for the summation of there are two degree values like theta 1 plus theta 2. Then we have that another topic. Yeah, now we can continue with the next topic, that is called as general pivot point rotation. So it can be supported. There are two methods. One is the translation and rotation. This general point pivotation is not supported to the scaling operation. So we can learn there are two methods, like one is translation and rotation. We can have that method with a graphics package that only provides a rotate function by resolving objects about the coordinate origin. We can generate rotations about any selected pivot points like y. Then performing the following sequence of translate, rotate, translate operation. So the translate the object so that the pivot point position is moved to the coordinate origin. Then rotate the object about the coordinate origin. And final one, the translate the object so that the pivot point is returned to the original position. Like it can be expressed in the form of like T of x or that means x rotation, then y or then y rotation into r of theta, that means rotation of degree, dot P of x y, then equal to finally r of x y theta. This is what we can use for. There are two methods we can implement with the concept of the pivot point. So this is for the topic of the pivot point. Next we are going to come to get the composite transformation. The next method is called composite transformation. The composite transformation is nothing but simply we can say about there is a unit vector along a axis of the coordinate system like T of Tx, Ty dot R of xr, yr, theta. So here we can represent in the concept of the rotation cos theta minus sin theta, then sin theta, cos theta, then 0, 0. The same thing we have applied for that x of 1 minus cos theta plus y sin theta plus tx, and we can have 1 minus cos theta plus x sin theta plus ty. This is what we can apply for the concept of the composite transformation. Then we can get for other transformation Earlier we have discussed about the shearing and reflection. You know that idea about it, what is shearing and what is reflection. The shearing is nothing but we can distortion of the image. So how you have done the method for the distortion of the image, you can, whether the value the x can be distorted of the y, so that we have taken it in the shear part. And the same similarly we can, the y can be distorted of the x, then we are going to take it in the part of the object. Then next matrix vector representation of shearing, we can have, there are two kind of things we can use here. There is the, what is the x direction shearing and the y direction shearing. The next topic is called as 2D weaving. So what is 2D weaving? When we define on image in some wild coordinate system, to display that image, we must map the image to the physical output device. This is a two-stage process. Like for three-dimensional images, we must first determine the 3D camera viewpoint called the view reference point. That it is called as VRP. That means view reference point and orientation. Then we project from 3D to 2D. Since our display device is two-dimensional, next we must map the 2D representation to the physical device. So this will first discuss the concept of a window on the world, that means WC, World Coordinate Systems. And then a viewport, that is called as NDC, that is called Normalized Device Coordinate, NDC. And finally the mapping between the WDC to NDC or PDC. Like we can have that world device coordinate to, we are going to convert into the, there is normalized device coordinate. So, and finally we can take it in the part of the object or image PDC, that is personalized the device coordinate. So what the man can view the objects like from the x and y axis. This is called, we are using the method for, we can have the 2D weaving. Finally, how you are weaving the device or the object is for the 2D. The next operation, it is called as weaving pipeline. So the weaving pipeline is nothing but is a world coordinate area selected for display. Is called a window. On area on a display device to which a window, this map is called as viewport. The window defines what is to be viewed. The viewport defines where it is to be displayed. So upon that windows and viewports are rectangles in standard position with the rectangle edges parallel to the coordinate axis. In general, the mapping of a part of world coordinate C to device coordinate is referred to as weaving transformation. Sometimes the window two-dimensional weaving transformation is simply referred to as the window to viewport transformations or the windowing transformation. This is called window to viewport. So the next heading is called as, next topic we are going to see about the weaving coordinate reference frame. This can be system provides the reference frame for specifying the world coordinate window. So we can use the world weaving coordinate system using the procedure. That is origin is selected at some world position, like you take it in the point P0 is equal to x comma y0. That means the two-dimensional weaving means we are getting for world IV or x view. A weaving coordinate frame is moved into coincidence with the world frame in two steps. You take the first step number 1, that is translate the weaving origin to the world origin. Then number 2, it is called rotate to align the axis of the two systems. We apply the matrix for converting world coordinate positions to weaving coordinates as a two-step composite transformation. We can have the composite two-dimensional transformation to convert world coordinates to weaving coordinate S, where T is the translation matrix that takes the weaving origin point P0 to the world coordinate or world origin, and R is the rotation matrix that aligns the axis of the two reference frames. So these steps to be in the coordinate transformation system. For example, we can say about the windows to viewport coordinate transformation. About window, we are going to look at and see about the What is window? When we are getting for that, the world device coordinates we can represent it as the concept of the window. And we can have that as a portion of the interest which is a polygonal area specified in world coordinates called the window. So what about the another concept that is called viewport? We are going to look it in the topic for viewport. What is viewport? The viewport is nothing but the user may want to create images on different parts of the screen. So we can define a viewport in normalized device coordinates, and we can have that using NDC, that is normalized device coordinates, is also for output device independence. We can have that we are converting from NDC to physical device coordinates. So we can have XW minimum, and we can have XV minus XV minimum. Then both we can using for the formula to find between the conversion of the NDC to PDC. That means the normalized device coordinate to physical device coordinate. Similarly, we can the extending of the x-axis value, that is XW maximum minus XW minimum. The same concept, it is XW maximum minus XW minimum. YW minimum, that YW maximum, like that we can take it. So the next one concept, it is called 2D weaving functions. Another heading, the following function evaluate weave orientation matrix like x0, y0, then x vector and y. Then error also we are getting for that when we are going to do the operation of the weave orientation matrix function. We can have the weave matrix one, the xv, that is x v port, and yb, that is x yb port, or the world coordinate position or the view of the vector. To set up the elements of a window to viewport mapping matrix, we invoke the function next. We can store combinations of weaving and window weaving viewport mappings for various workstations. For example, we can say about it is a set view representation of WS, weave index, weave matrix, weave mapping matrix, X clip minimum, X clip maximum, then Y clip minimum, then Y clip maximum, then clip PXY, where parameter WS designates the output Y, that is called workstation, and parameter weave index sets as the integer identifier for this particular window viewport path. The final topic of this unit we can have about that is clipping operations. So what about we are going to see and look about what is first of all clipping. The clipping has done whether that the portions of the image, some of the portions it is inside, some of the portion is outside. Whenever the outside of the portion if it is available, that we want to do the operation by using the clipping. So that concept we are invoked and we are going to clipping and cut it out. So that is called clipping operation. So that is clipping refers to the removal of a part of it. See, internal clipping removes part of the picture outside a given region. The external clipping removes parts inside a region. There are some different kinds of clippings are available. We can have, there are 5 types. What are the 5 types of clipping? One is point clipping, the line clipping, area clipping, curve clipping, and text clipping. We are going to look into the first one, that is called point clipping. The point clipping is nothing but whether the point, if it is inside on the screen, so that we are going to save and store that point on the screen. That means on the memory. Where we have stored the point, we are going to store on the memory. So suppose if the point, if it is on outside of the window, that we can remove it. That is called point clipping. So what are the conditions you are going to take it by using the operation by done point clipping? That is XW minimum less than or equal to X less than or equal to XW maximum. And simultaneously, not only for we are looking for the X value and Y also we can take it to the path. So there is YW minimum less than or equal to Y and less than or equal to YW maximum. So generally we could call it what is pixel. We can represent so the value of the coordinates of X and Y, that is called pixel. So like that we are getting for the first one operation as done by the point clipping. Then we are getting for the another second clipping operation, that is line clipping. We are going to get into the line clipping is the process of removing lines or portions of line outside of an area of interest. So this for typically any line of code thereof which is outside of the weaving area is removed. So whenever we are going to do the operation, how we are performing in the line clipping, so the line if it is fully inside, we want to store it. and the memory. So suppose in the line, if it is partially inside and partially outside, so which are the portions are outside of the screen or window, that we want to remove it. That is called by using the clipping operation. So suppose some of the line is fully outside, simply we doesn't bother about it. We can remove it. So there are three ways we are going to represent for the line clipping. One is that is fully inside, and some line it gets for partial inside or partial outside. So whenever the partial outside, you want to remove it by using the clipping operation. So whenever we are going to fully outside, that we want doesn't bother about them, simply we can clip it. That means we are avoiding. So there are three ways we are representing for the method of the line clipping. And we have got the another clipping that is called the area clipping or polygon clipping. What is another name we are going to use for the area clipping? That is called polygon clipping. So how we are finding and how the algorithm has been implemented in the method of the polygon clipping, we can have, there are some dimensions we are performing, like we are top, bottom, and we are getting for left and right. How we are defining for that left, right, and top, and how we are going to operation as done. In order to the operation as done, the top, first one, then we are getting for left clipping and right clipping. Finally, we are going to get the bottom clipping. This is the way you want to get for the method of the polygon clipping. The shape, the image, it has some polygon image. They are taking the image that is called polygon image. That kind of image, so you can remove first top, then get for left, and we are going to get for right, and finally it is for the bottom. So this is the way you are going to do for the operation of the polygon clipping. And fourth one, so we can have that is called text clipping or all or none clipping. For example, you can say about the text clipping or all or none clipping. The individual character, if it is inside of the screen or window, we can save it. Suppose some of the word it is on the line. That means it is the border of the line, so you can remove it. So then some of the text it is fully outside, you can remove it. Some of the text it contains for fully inside, you can save the text from the memory. So this is what we can do the operation in the text clipping. And finally, we can have that is called curve clipping. So which are the portions if it is inside that we want to store on the memory? Which are the portions are outside that simply we can remove from the memory. Then we remove from the portions of the picture on the screen. So that by using the curve clipping operation. So there are some 5 kind of clipping operations. One is point clipping, line clipping, area clipping, text clipping, and curve clipping. That's all about it, clipping. Okay, now I want to conclusion about the unit. So what are the topics we have covered? Like we are having that what is graphics and how we are going to use the graph by using the animation. Whenever you want to do the animation, we need to get some transformation. So there we can use for the basic transformation or 2D or geometric transformation. Then we have done the method of composite transformation, and we have done the method of matrix representation. Then we have that about the 2D transformation, rotation, scaling, and we have translation operation has been covered, and the general pivot point operation when we are going to do, there are 2 operations majorly performed. One is there is translation and rotation only. Then we have done the composite transformation. Then other transformation also we have covered. There are 2 kind of thing. One is there is reflection and shearing. Then we have that other kind of the vector representation also we have seen, and we have seen like 2D weaving functions and weaving pipeline and weaving coordinate reference frame and Windows to viewport coordinate transformation and 2D weaving functions. Then finally we have done the method of the clipping operations. So thank you.